Hi, I'm Donna Okazaki, and I write Python for Granular. And I have a passion for unraveling obtuse problems like, why is my tractor in the Gulf of Mexico? This I found while having fun fitting geometry around machine reported GPS coordinates. It works. So I'm not going to read all of this because I'll run out of time. So I've got kind of a condensed script here that I'll go off of. So modern agricultural machines are strapped with sensors that provide measurements that need to be transformed to make them usable for analysis. For example, this boundary is fitted around the coverage path of a harvester that's harvesting corn. It's tightly fitted, so the points here show you the actual path of the GPS coordinate measurements. And using the sensor width, we basically build this geometry that is the fitted boundary around where the actual machine traveled and collected grain. So you can, so part of this, you can use this to show what percentage of the field you actually harvested. So geometry is a very useful derived piece of data from the raw measurements. Now this page gives you the core of the algorithm that I actually implemented to do the fitted boundary around the harvest path. And I used Python for it using NumPy, Shapely, and PyProj. And kind of in summary, this algorithm that generates this boundary essentially just takes the sensor's GPS coordinates, collects them into arrays of segments that are then dilated by the width that each sensor covers. This results in polygon strips that are unioned into the coverage polygons. So this is all well and good as long as the data is well behaved. But when it's not, you get this. So here, this is actually from a real data set, and it contains two GPS reading anomalies, one up here and one down here. This is the one that led to my question, why is my tractor in the Gulf of Mexico? The actual fields are in this tiny little corner up here, and this purple spike here shows you the, it's a convex hull around all the data points. So this is the real mystery, but before we get to that, let's take a look at the first anomaly. Now this is actually pretty easily explained. It happens to be a single GPS point that's repeated for about 4 minutes that started at the earliest time of the earliest piece of data within this entire data set, which is chopped up into what we call operation regions. So this can be explained by perhaps at machine initialization, there was some corrupt data or just some initialization error where it was recording garbage for a while. And then half an hour later, it starts here right next to the field. And we can use a very simple geodetic distance filter based on reasonable max machine speed because there is no tractor on Earth that can go 200 kilometers an hour. But the question is, even though we have some bogus points here, what do we do with those points that have bad GPS because the measurements collected are more than just GPS coordinates? So take a look at here, and it really depends on the domain. With the data that's being collected here, we're lucky that we have a specific property that is recorded with each point. That is whether the machine is engaged or disengaged. And using that property and analyzing the bogus data, we notice that it's only in the data that is disengaged from operation. So it's not actually harvesting corn at that point. So we can differentiate disengaged points from the engaged, which are here shown with a boundary around it. So the solution is to limit our complex geometry calculations to just the engaged data. And the disengaged data, we just leave it as point data. Going to our back to our favorite question, why is my tractor with the snorkel in the Gulf of Mexico? This one is kind of interesting because this happens throughout the data set, and it's intermittent. But on further analysis, what I found was that it's a single coordinate out to 6 digits of precision. We're right in the middle of the Gulf of Mexico, and it only occurs during disengaged data. Okay, yeah, and so the same solution applies. We only do the fitted data around the engaged data points, and we're able to have nice fitted boundaries around our engaged data and retain the disengaged data as just points.
Thank you very much. Round of applause.